All right, today we're going to pull back the curtain on the invisible magic that keeps the entire modern internet running. We're talking about Kubernetes.
Have you ever really thought about that? I mean, you tap an app on your phone and poof, it just works. You go to a website and it's always there, always on. Trust me, this is not an accident. It's the result of solving one of the biggest, most complicated challenges in modern software.
You see, the incredible reliability we all just expect now comes from a complete revolution in how we build and manage apps. And to really get why the solution is so brilliant, we first have to understand the problem.
So back in the day, applications were built as one giant block of code. We call it a monolith. And the problem was, if one tiny part failed, the whole thing could come crashing down. But the new way? It's all about microservices. Modern apps are broken down into hundreds, sometimes thousands, of tiny, independent services. Think of it like swapping a chaotic one-man band for a full, perfectly coordinated orchestra.
But just imagine trying to conduct that orchestra without a system. You've got hundreds of musicians. They all need to be managed, started, stopped. And what if one gets sick? You have to replace them. It would be absolute chaos. And that is exactly the problem developers were facing.
So the first step to taming this chaos was this amazing technology called containers. The best way to think of a container is like a perfect soundproof practice room for each musician. It packages up the service and absolutely everything it needs to run, which makes it consistent and portable no matter where you put it.
But, even with all these perfect little practice rooms, you still need someone to lead the performance. You need a conductor. And in the world of software, that conductor is Kubernetes.
To put it simply, Kubernetes is the master orchestrator. Its whole job is to manage the entire life of all of those containers, making sure that the entire orchestra plays in perfect harmony to deliver that seamless experience that you and I expect.
But here's something that's really important to get. Kubernetes is actually bigger than just managing containers. It's a super powerful, abstract management layer for applications. The thinking is, containers are just the best instrument it has to work with today. The system itself is designed for whatever comes next.
So how does a developer tell this digital conductor what to do? Well, they don't just shout commands. Instead, they provide really detailed sheet music, and that comes in the form of configuration files. So let's take a look at the basic notes.
Okay, the most basic note on the sheet music is called a pod. It is the absolute smallest unit that Kubernetes deals with. A pod can hold one or more of those containers that are really tightly connected. A great analogy is a string quartet. These musicians are always scheduled together on the very same server because their parts are just inseparable. Next up, we've got a service. Now, a service provides one single, stable network address for a whole group of pods, and this is so critical. It means that even if individual violin players come and go, maybe they get replaced, the audience, the user, can always hear the violin section at the exact same predictable spot. And finally, we have the deployment. This is the big one. This is the full score for the entire piece of music. It tells Kubernetes the desired state of the application. That means which version of the code to run and exactly how many replicas or musicians it needs playing at all times.
And right here, this is where the magic really happens. Because once the conductor has that score, it will do absolutely anything to make sure the performance matches what's written down 24/7. It literally creates a self-healing orchestra.
So what happens when things go wrong? Because they always do. What if a server, one of the stages in our orchestra, suddenly just goes dark and all the musicians on it just disappear mid-performance? Kubernetes doesn't even flinch. The conductor immediately notices a musician is missing. It looks at its score, that deployment file, and sees, hey, I'm supposed to have 3 violinists. So it finds a healthy server with an empty stage and instantly creates a new replacement pod. And for the audience, the music never stops, not for a second.
And this system isn't just for when things break. Nope, it's also for handling success. So what happens if a massive crowd suddenly shows up for the performance? Well, the conductor can read the room and scale the orchestra instantly.
So let's say you start with 3 pods running your application, just handling the normal, everyday traffic. But then, bam, a huge traffic spike hits. The developer can just update one number in the deployment file, and Kubernetes automatically and almost instantly scales up to 10 pods to handle all that new load. And just as important, when the traffic dies down, it scales right back down. It's perfectly elastic. So when you put all of this together, the conductor, The sheet music, the self-healing, the scaling, you get more than just an application. You get a never-ending performance. So it really all boils down to 3 huge benefits. First, reliability, thanks to that amazing self-healing we just saw. Second, scalability, so it can adapt to demand in real time. And third, efficiency, because when you manage resources this intelligently, no server hardware ever goes to waste.
And that brings us right back to our first question. Why do your favorite apps almost never go down? Because of this. Kubernetes is the invisible, tireless conductor working behind the scenes, making sure the performance never, ever stops. It is the backbone of the always-on world we now just take for granted.
By automating all the chaos of managing the orchestra, Kubernetes frees up developers to focus on what really matters, writing the music. And that leaves us with a final thought. If the conductor is a machine, what incredible new kinds of symphonies will humans be inspired to create? Thanks for digging into this with me.